please welcome?
Thank you.
Can you please take some
Hi,
photos?
my name is Kimsia. I'm from Singapore. I'm a developer, and this is Vikram here. He's an open source enthusiast and developer consultant with Dagger.io. He's a published author of 7 books, and this is our first time collaborating. We met through Discord, on Dagger Discord, in fact, and 2 years ago we catch up for coffee, and next thing we know, we are presenting this today for the first time. So, Vikram.
Hey, Kimsia. Hi, everyone. Welcome to our talk. Like Kimsia said, we actually planned this talk. We met over coffee, and we were thinking about self-healing pipelines. And this was in December, so we proposed this talk. And actually, things have moved so fast in the last few months that this actually became a reality. It was actually quite an interesting experiment that we built. Before we start, I want to talk a little bit about the title. Like we're saying, this is a self-healing pipeline. Just explain a little bit what that means. So if you're a developer, imagine a scenario, you add a new feature to your code, you push it to your repository, and you have a CI pipeline that gets triggered, right? And that CI pipeline is going to do a bunch of things. It's going to lint your code, it's going to run your unit tests, your integration tests, it's maybe going to run a build, maybe it's going to upload an artifact to a registry or to a remote storage. But if there's a mistake in your code, all that will come to a stop, right? The pipeline will fail. And then it's up to you as the developer to figure out, hey, what went wrong? I need to debug it, and I need to make some changes so that everything works. And what a self-healing pipeline is that it takes away a lot of that work from you. It's actually going to, on its own, investigate what happened, and it's going to come back and it's going to give you suggestions, or it's going to make the fixes automatically, so that your test pass and your pipeline works. And I know this sounds a little bit futuristic, maybe science fiction kind of thing, but with an LLM, this is actually reality today, and we're going to show you a demo actually of it in action. So that's about the topic. I want to turn it over to Kimsia now, and he's going to talk a little bit about CI pipelines.
All right. Thank you, Vikram. So hands up, anybody understands the concept of continuous integration, CI? So that's most of you. Thank you very much. For the benefit of those who are a little bit not familiar, even though Ludovic covered it brilliantly just now as an overview. So continuous integration is about the speed at which you want to deploy the software, like I said very brilliantly. And we all started in a very simple manner, right? Maybe a few scripts in the beginning, maybe we use something like Ansible, Playbook, that sort of thing to help us quickly package our software and deploy it. Now, usually we have 3 types, right? Mobile app, a desktop app, or web application. Now, the first 2, we probably need to package it into an executable installable executable package. The third one, we want to deploy the software to some web server, right? So we would like to keep things simple. So over time, we would add more things, like maybe we want to automate our lint check, our unit tests, and things will start to become a little bit more complex. So, and that's when we start to see the image on the right-hand side, right? So things have become more complex for our continuous integration script. And as time goes by, especially now in the age of automation, we will now introduce AI agents and LLMs into our CI process, because we all want to be more productive, right, as developers, and that actually adds more chaos, and we need to work with different teams. Maybe we need to work with QA, and things become much more chaotic over time. And what's wrong with CI can really be boiled down to 3 main factors. Number 1 is that what we call reproducibility. Hands up for those in the audience, does this look very familiar to you? Yes, very much. Okay, we call this the push and pray, right? The push and pray. It works on our laptop, but we are not sure if it actually works in the CI server. So we push and then we pray very much to the gods of CI servers that yes, it will get past our Jenkins and what have you, right? But after a while, you have to try the second time, and then the third time, and then the fourth time, and the fifth time, the sixth time, and so on. So you probably get the idea, right? The second type of issue we have is, maybe your team originally started off something simple, on GitHub Action, but it's still not enough, or maybe your team wants to cut costs. They want to move you to something even better and cheaper, like Circle CI and stuff. So you may have issues migrating your CI scripts from one provider to the next, right? So that is our second problem, portability, right? And the third problem we want to do, so when we are trying to port over, we want to keep both, because you cannot just swiftly just migrate easily, right? So portability is an issue. Now, the third thing we want to do is complexity. So on my right, your left, day one, you've kept things pretty simple, easy to read. Now, over time, as you add more changes, because your software is taking off, you're going to add more steps to your CI process, things become more complex, and so on and so forth. So now it becomes very hard to find out what went wrong during your CI process. Is it something on your script, in your automation script? Is it something on the CI provider? Is it something that occurs between an interaction between your script and the CI provider? So that becomes very opaque and hard to decipher. So these are the three problems of CI processes today. So I'll hand over to Vikram, who's an expert in Dagger, to tell you more, because Dagger allows us to set a foundation to have solved those three problems that I've pointed out earlier, and also allow us to take advantage of the immense growth in terms of LLM automation. So back to you.
Thank you.
Yeah.
Okay, thank you, Kimsia. So that's a really good description of some of the problems and some of the patterns that people are seeing in CI today, some of the frustrations that a lot of people in this room have probably experienced as well. So I want to talk a little bit about Dagger. Dagger is an open source tool. It's actually been created by the founders of Docker. You see them in the photo over there. And this is kind of how we describe it. It's an open source tool which lets you build composable workflows. And those could be CI workflows. It also works for AI workflows, any kind of complex workflows which need to be repeatable, work consistently, and be completely debuggable. So I want to describe a little bit about it. So some of the key features, containerized workflows. So everything, all workflows in Dagger run in containers. Because they run in containers, they are immediately reproducible. You can run them on your laptop, you can run them in a remote server. They're always going to work the same way. So a lot of the, the slide that you saw earlier, the works on my laptop problem and the push and pray problem, they just eliminated because of this. Because if the workflow runs on your laptop, it runs in a container, it's going to run the same way wherever you run it. We have in Dagger, we have what we call a universal type system. So your Dagger workflows are made up of functions and modules. And those functions and modules can be written in any language. And not only can they be written in any language, but you can plug and play those modules to create your workflows. So for example, let's say you have a workflow which needs to, at the end of its process, needs to upload an artifact to S3. And there is a Dagger module written in Go, which does that job. But your app and your pipeline is written in Python or in TypeScript. You can actually plug that Go Dagger module into your workflow and just use it natively in code, just as you would write normal Python or TypeScript code. The next thing that we have is actually another one of Dagger's superpowers, which is caching. So every operation in your workflow is cached. And that means that when you rerun that workflow, the steps which were the same, they just, sorry, I need to get the, okay, yeah. Those operations are cached, and this caching works for both LLM calls, API calls, all of that. And so that means when you run your workflow the next time, the steps which are cached, they just pulled from the cache. So your workflows are going to run faster. And for example, for CI pipelines where you're charged in in seconds or in minutes, because they run faster, they're also going to cost less. We have built-in observability. This is a key feature for debugging. So I'm going to show you a little bit in the demo, but Dagger gives you logs, metrics, complete traceability of the workflow, so you can see exactly what is happening at any given time. And you can also share those debug traces with other members in your team, so people can collaborate and work together to figure out what's happening. It's a completely open source tool. All our code is on GitHub. We do all our development in the open. So you can drop by a GitHub repository. You'll see things that open issues, things that our team is working on. You can contribute. You can write an issue if you have a problem. You can contribute solutions, open pull requests, and all of that. And also, because it's a completely open platform, you have all those benefits of openness, right? You can experiment very freely. You don't have any vendor lock-in. You can switch from one CI provider to another. You can switch your tech stack. You can do all of those things very easily. Um, we have native integration with almost all the LLMs that are available today. And integration is actually very interesting because when you integrate Dagger with an LLM and you give it your workflow, it can automatically explore that workflow, explore the functions available in that workflow, and start actually operating and using those functions with the LLM augmentation. And finally, we have interactive terminal. This is again a very powerful debugging tool. You can drop into your workflow at any point, see the state of your containers, see the state of your services, even make changes if required, and it helps you debug things a lot faster and get things working very quickly. So this is kind of everything that makes up Dagger. It's a big diagram, so I'm just going to point out some of the things. So at the core of what we have is the Dagger engine. This is a specialized engine for running workflows, and you interact with this engine using SDKs. So we have officially we have 3 supported SDKs, which is Go, TypeScript, and Python, and that means that you can write your pipeline in any of those languages. So you write your pipeline in code just like you would write your application in code. You write the pipeline also in code. You can pull in. You have access to your entire languages ecosystem, so you can pull in third-party modules from npm if you're using TypeScript, or from PyPy or any of those things. In addition to the officially supported 3 SDKs, we also have community generated SDKs. So we have community SDKs for PHP and for Java, and there are other languages also which are being developed. And if there's a specific language that you use regularly, which you don't see an SDK for, as I said, we are completely open. You can hop into our Discord and you can start developing an SDK for that language and contribute it back to the community. Coming to the left side of the screen, we have Dagger is completely vendor agnostic, so it works locally on your laptop. It works with every CI provider that's currently available. It's also very easy to switch from one CI provider to another. With this kind of addresses the portability issue that we talked about earlier. At the top is Dagger Cloud. Dagger Cloud is our web dashboard for tracing your workflows for debugging. And I'm going to show it to you in a little bit, but it's basically the tool that you would use to understand what's happening in a workflow, to identify errors, to collaborate with your teammates on figuring out what went wrong and how to fix it. And finally, on the extreme right, we have what we call the Daggerverse. I mentioned a little earlier that your workflows are composed of Dagger modules and Dagger functions. And those Dagger modules and Dagger functions can be published online in our catalog, which is called the Daggerverse. And that lets anyone search for a module that does a specific thing and just plug it into their existing workflows. So these are user contributed modules from the community. They are all, you can go in and you see for each module, you see what the API is, you see some examples of how to use it, and you can obviously inspect the source code as well.
Right. Just to quickly add on, as a developer, I'm not with Dagger, but the way I discover it is because I really hate writing the YAMLs and learning all the syntax. We all prefer to use our own preferred language, right? Like, for example, I prefer using Python, and that got me interested because I could easily use their SDK to write my own CI process. And that's how we got to start talking about it. So this is my favorite part of the whole platform.
Yeah. So the interesting thing is that if you're writing your Dagger pipeline in any of the supported languages, you're writing it in your IDE. So you're getting all the IDE benefits as well, like you see the auto completion and the code intelligence and the language hints and all of that stuff. So it makes it very fast, very easy. It's a very native experience. So you feel like you're writing your pipeline in whatever the languages that you're most comfortable in. I want to spend like a minute talking about our LLM support, and this is just a couple of code examples. As I said, we have native LLM integration with almost all the models that are there available right now. And the way it works is that you can create a Dagger agent which connects to your LLM. You can see it in the right box, and you give it what we call a workspace. And that workspace, you kind of define what the workspace is, but usually it's going to be a container or a set of containers, maybe with your source code or assets that you want to operate on, and you give it a set of tools, and those tools are Dagger functions. So if you look on the left side, we've got an example workspace module, and you can see we're giving it, setting up a container with some source, we're setting up some tokens, and we have a couple of functions there like test and write file. So these are tools, and when you connect the LLM to this workspace, it can explore the workspace, it can understand what it can do, what are the tools available to it, and then you can actually give it instructions or assignments and say, hey, this is the source code, this is the tools, I want you to do X, Y, and Z. And we're going to show you this as well. So yeah, so that's the main kind of the talking part. Let's get to the good stuff, which is the demo.
Right.
So
I can hold this for you.
Okay, thank you.
Right. As Vikram is setting it up, so I'm just do a very quick, brief overview of what's going on. So what Vikram has done is that he has a Python-based fast API sample app. We will share the links with you at the end of the talk. And what happens is he's gonna purposely send in a faulty pull request that will trigger failed tests, and then we will see the LLM kick in to help resolve the issue. Right.
Yeah. So this is actually this is the simple fast API app. It's just API REST API with some endpoint, and it's a simple API which just lets you add and remove books from a database. And we have a data model. And what I'm going to do is right now, it's all working. So
I'll help you to hold.
yeah. No, it's okay. So what I just kicked off here is it's a Dagger function called test, and what this test function is going to do is it's going to create a workspace. It's putting the source code of my app into it, and it runs PyTest. It's a Python app. It runs PyTest, and we should see thing to it, so it should be working hopefully. Yeah, and you can see all this, so it worked, right? And now we're going to deliberately put an error in. And what I'm going to do is this is my sorry, yeah, thank you. What I'm going to do is this is my base class for my API, and let's add a field here, right? So we have title and author fields, and what I'm going to do is add a field. Let's make it a little bit more difficult for the LLM, and we make that and so this is all I'm going to do, right? This is let's say a junior developer, right? He's done this, he doesn't know what happens, what else he has to do. So he says, okay, cool, this is the change that I'm making. And now obviously let's run that test again. And now in this case, we've added some code, we've not updated anything else. We've not updated any of the other files, we've not updated the unit test, we've not updated the repository. So there's obviously going to be some problem. So let's have a look. Yeah, so you can see as you can see, there are some test failures over there. And so this is the point where if this was in CI, your CI would give you a big red danger symbol and come back to you, and you'd be like, oh, okay, something went wrong. Now I need to go in and figure out, look at the debug messages, try and figure out what went wrong. But we don't do that today, right? Today we're going to have the LLM do this work for us. And so now I'm going to run a different function. It's called heal. And this is the function which actually is going to bring in the LLM integration. And so this is going to take a few minutes because what's going to happen is that the LLM is going to have a look at the code, run the test, figure out what went wrong, and it's going to try and fix it. So while this is happening, it's a little bit hard to read this, but I mentioned some time ago we have this tool called Dagger Cloud, which lets you see exactly what's happening. And so I'm going to switch to the traceability tool so you can see a little better what's happening here. So this is Dagger Cloud. It's a web-based dashboard. And this is actually our Dagger team's dashboard. So you can see our team working on stuff in real time. And this is the function that I just ran. And what this is going to do is it gives you what we call a trace. And a trace is a very detailed insight into what is happening in the workflow. And let me scroll down a little bit. And so this is the prompt that I'm giving the LLM in this case, right? We're telling the LLM, you're an expert Python developer. Here's some source code. Here's some tests which are failing. You fix it. And we're giving it some rules, some kind of guidelines as to what it should do. Make your changes, run the test, keep going, don't stop until the test until the test pass, and so on. And so let's see what exactly it's doing, right? And so the first thing it did was it ran the test. It saw that there are a bunch of failures, and you got a full stack trace. This is the stack trace from the failing test. It's a long stack trace. And this is what the LLM actually analyzed, right? And it figured out, okay, the problem is related to the field that I just added, and it's giving us a plan of action. Okay, it's like, okay, this is what I'm going to do. I'm going to fix these other files. I'm going to fix the test and all the rest of it. And you see, these are the tools that it has, right? It's figured out that there's a thank you. It's figured out that there's a tool called read file, and it's using that to read the files. And as we come down, it gives us, it tells us what it's found, this is what it's found, etc., etc. And then it's also found a tool that we have in the workspace, which is called write file. And these two things are giving it what it needs to understand what's going on and to make fixes to the pipeline. And look, it did it, right? It figured out, okay, this is what I need to change. And it says, this is, I changed, I changed the model, I changed the repository, I fixed the unit test, and everything is working as expected. Let's see if it is, right? So let's go back to my VS Code. And if you remember, I only changed the models.py file, right? This is the line that I added. Now let's have a look and see, there are more things that, so you can see the LLM has added this. And if we go into you see it's also updated this file. This is LLM generated fixes. This is my test data, and it's fixed this. And so let's test if it actually does work. We're going to run the test function again. And this will take about a minute or so. I'm not sure if do we have, how much time do we have left?
Less than two minutes. We should give you a break. We don't want to be the ones holding you back from your break. So
yeah, if we can get everyone for about maybe 3 minutes more. So as you can see, this is now the tests are passing. We didn't really do anything here, right? All we really did was tell the LLM, hey, this is broken, you need to fix it, and we gave it a bunch of tools to actually do what it needs to do. So this is kind of a self-healing pipeline, but there is another version of this as well, which we have, right? So this is running locally on my laptop. Imagine if you want to integrate this with GitHub. So we don't have time to show you all of that, but I'll quickly show you something that we ran a few minutes ago.
I hold this one.
Okay. And so so this is an example of the same code, same application on GitHub. And what I did was I opened a pull request with a change, and it was a deliberately breaking change similar to what I just did. And we had the LLM run over there. And in this case, because it's a pull request, you could also have it change. But instead, what we did was we just asked the LLM in this case to review and to provide feedback on the pull request. And if you look, it did pretty much the same thing. It analyzed the code. It gave us a proposal saying that this is broken. This is what you need to fix. And not only that, it also generated a diff for us. So if you're we all like to be lazy programmers, right? So in this case, you just take the diff, you apply it to your code, and things should pass. So
I guess that's a signal
I guess
for us to wrap it up.
oh, it's back. Okay, we're just going to say the LLM is watching us right now. The AI is watching us and wants us to shut down. But yeah. So that's actually the end of our talk anyway. So let me just put up some links here. So for those of you who are interested, if you'd like to learn more about Dagger, please join our Discord. I'm in the Discord. Our whole team is in the Discord. You can ask us for help, or if you need, just some guidance. We have a quick start, which gets you started on all of this stuff. And if you'd like to try this demo app, you can just clone it from there, and you can try it. All you need is an LLM key, like an OpenAI key or an Anthropic key or whatever. Plug it in, and you can try the demo on your own laptop. Yeah, and I think we're out of time. But if anyone would like to see a little bit more, understand how it works, we are around. Just come and grab us. I'll be at the back for a little while. Yep. Thank you very much.
Thank you.
Thank you very much, Vikram and Kimsia, for the demo. And for the next class, we're going to have a break. Thank you very much for joining, and we will be. It is a